Hi, my name is Alondra Rivera, and I will be presenting the introduction. So, in this lab, we explored how objects can become charged and how they interact with different materials. Last lab, we only observed charged objects, but now we were able to make predictions, test them, and record our results. Using tools like the electrometer, rods, and simple materials such as aluminum foil and pith balls, we looked at charging by friction, conduction, and induction. This helped us see how charges move, how polarization works, and when the objects attract or repel each other. All these processes fall under something called electrostatics, which is the study of electric charges at rest and the forces they create. Our hypothesis for this experiment was that the pith ball and the aluminum foil would be attracted before the rod was touching it, and then they would repel after contact with the rod.
The materials used in this lab experiment were an acrylic rod, glass rod, a PVC rod, fur cloth, silk cloth, wool cloth, an electron meter connected to an ice pail with a dangling aluminum foil, a hanging pith ball, and 2 spheres. The acrylic rod, glass rod, and PVC rod were all charged with rabbit fur, silk cloth, and wool cloth.
We started this experiment by using an electroscope. We first measured the type of charge acquired by different rods when rubbed with various cloths. For example, how the PVC rubbed with fur took on a negative charge, while a glass rod rubbed with silk became positively charged. This gave us a reference guide for identifying charges throughout the lab. In part A, we examined the interaction between a charged rod and a neutral conductive grounded object, in this case a piece of aluminum foil. When the rod was brought close without touching, the foil responded due to the movement of charges within it. We observed whether the foil was attracted to or repelled from the rod, showing how grounding affects the way charges behave. In part B, we tested what happens when the rod and foil are separated, and then brought together again. This step highlighted whether the induced charge on the foil was temporary or if a lasting effect remained after separation. In part C, we repeated the procedure but replaced the foil with a neutral, isolated pith ball. Since the pith ball was not grounded, it could only react through polarization. Bringing the charged rod near the ball allowed us to see how charges inside the ball shifted, producing attraction or repulsion depending on the situation. In part D, we separated the rod and the pith ball before bringing them together again. This allowed us to compare the effects of grounding in part A with isolation in part C, deepening our understandings of how different materials respond to charges. Finally, in part E, we explore polarization and induction in more detail. We began by placing 2 spheres together so they were in contact. Next, we positively charged an acrylic rod by rubbing it with fur and carefully brought it close to one of the spheres without touching it.
Okay, so now for data analysis. So for the first part of the lab, we used an electrometer to measure the charges of different charged rods. The first rod we tested was acrylic, and with fur, silk, and wool, the rod ended up being positively charged. The second rod we tried was glass. The same as the acrylic, with fur, silk, and wool, it was positively charged. Then the last rod that we tried was PVC or plastic, and with fur it was negatively charged. With silk and wool it was positively charged. Now for the next parts, part A to part D, we ended up choosing the acrylic rod charged with fur to do our experiments. So part A was charging the rod and then bringing it close to an aluminum foil. The observation to this was that the foil was attracted to the rod, and or analysis of this was that the rod's positive charge attracted the negative charges on the foil, inducing polarization of the foil, causing it to attract. You can see that in this video. Now for part B, where we charge the rod and then we touch the aluminum foil. Our observation for this was that the foil was still attracted even after them making contact and dissipating some of the charge from the rod. This was actually different from our prediction, which we thought that the contact between the rod and the foil would have caused a transfer of electrons from the rod and to the foil, resulting in equal charges, therefore repelling. But that did not happen. This attraction could have been the result of the contact patch that we made was not sufficient enough for enough electrons to be transferred, or the time that we left it on the foil was not enough as well. And you can see that on the top right photo of the acrylic rod touching the aluminum foil. And now for part C, where we brought the charged rod close to a pith ball. Our observations was that the pith ball was attracted to the rod, and then the analysis of this was that the natural pith ball became polarized due to the charge of the rod resulting in attraction. So now for part D, where we charged the rod and then we touched the pith ball. Our observation was that the pith ball was attracted to the rod, and our analysis is that once again, like the other one with the foil, this was different from what we had predicted. We predicted that the contact of the rod with the pith ball would result in a transfer of electrons, which would make them both the same charge. This attraction that resulted could have been a result of insufficient contact, or the result of the positive charge of the rod being so strong that it, even with the polarization, it's still attracted. So now for part E, where we charge spheres using induction. Our observation for this part was that the sphere closest to the rod became negatively charged and the one further away became positively charged. And our analysis is that induction occurred because the positively charged rod attracted the electrons within the spheres, pulling them closer to this, or pulling them towards the closed surface, resulting in a transfer of electrons from the further sphere to the closer one. And then after the two spheres were separated, the one further away was left with a net positive charge, and the one closest was a net negative charge.
For the conclusion, in this lab we tested the positively charged acrylic rod with fur with neutral, grounded, and conductive objects. Before we started, we predicted that the foil would be attracted before touching the rod, and it would repel after contact with the rod. With the pith ball, we predicted the same exact outcome. It would attract before touching and then repel after touching. In part A, we saw that when we brought the charged acrylic rod with fur to the neutral grounded foil without touching, the foil was attracted. This occurred because the foil became polarized, meaning the electrons inside of the foil shifted. The side closest to the positively charged rod became more negative, which caused the attraction to the foil. If you see in the picture above, we have the foil. It's neutral, it has an even amount of negative and positive charged electrons, and we have the positively charged rod. But then we introduce the rod and bring it closer. Those positively charged electrons shift away from the rod, and the side of the foil that is closest to the rod shifts with negative electrons, causing an attraction. In part B, we expected the foil to repel after touching the acrylic rod. Instead, it attracted. This attraction occurred because the foil might have not picked up a big enough positive charge during the contact with the rod, so it still stayed mostly neutral. Another reason for this attraction could be that the rod's positive charge was so strong that even after the polarization with the foil occurred, it still caused an attraction. As you can see in the diagram above, the first picture shows us touching the positively charged rod to the foil. As you can see, the positive charges are going into that piece of foil, so it's obtaining more positive charges. And then we bring back the rod in the second picture below. And when we bring it back, even though there's more positive charges there, it's still slightly neutral. So you still see that polarity, that polarization shift into the foil, where you have the positive charges going away from the foil and you have the negative charges coming towards the rod, towards the side closest to the foil. In part C, we saw that the neutral pith ball was attracted when we brought the acrylic rod close to it without touching it. Just like in part A, a polarization occurred with the charges of the ball shifting. The side closest to the ball became negative, causing attraction towards the rod. And then in the picture, you can see we have this positively charged rod. We're bringing it close to the pith ball, and the pith ball is neutral at first, having an equal amount of positive and negative charges. And when we bring this rod closely, the positive charges shift away from the rod and the negative charges shift towards the rod. In part D, we thought that the pith ball would repel after touching the acrylic rod, but instead it attracted. This attraction occurred because the pith ball might not have picked up a big enough positive charge during contact with the rod, so it stayed mostly neutral. Another reason for this attraction could be that the rod's positive charge was so strong that even after polarization with the pith ball, it still caused an attraction. And then as you can see in the picture, we are bringing the positively charged rod to the pith ball. This is going to then transfer some of that positive charge to the neutral pith ball. And if you can see down below, there are more positive charges now than negative, but still a polarization occurs because the rod charge is so strong, it still shifts and the negative charges go towards the rod and the positive ones go away from the rod. After contact, both the pith ball and the foil were expected to repel with the positively charged acrylic rod, but they attracted. This occurred because these objects only gained a small amount of positive charge, making it still relatively neutral. Also, the acrylic rod was strongly positively charged, as shown only on the electron meter, reaching the maximum positive charge. And if you could see the diagram, the picture on the right-hand side, this is us testing that rod. And when we use the electrometer, it reached its maximum. You could see it's positive 3.0, so it was very strongly positively charged. This strong charge from the rod still allowed for the charges of the positive to shift to the opposite end of the object, but the negative object still shifted towards the side of the rod, causing an attraction. In part E, we used induction to give these spheres a charge. When we brought the acrylic rod to the sphere on the right without touching it, it shifted the charges in the spheres around. The sphere on the right, closest to the rod, gained a negative charge, while the sphere on the left gained a positive charge when we introduced the positively charged rod to the right side. This occurred because when we brought the positive charge towards the right side, the positive charges in the spheres went to the opposite sides of the object, while the negative charges moved to the right, attracting towards the rod. We removed the sphere on the left and tested its charge in the electron meter, and it showed a positive charge, leaving the other sphere on the right with a negative charge. And if you can see on the right, this is the shift in charges. So we bring the rod close, it's positively charged, and it's going to go ahead and shift those charges together. Through induction, when we separate the balls, we give them both permanent charges. In conclusion, we learned that charged objects can interact with neutral objects in two different ways. It interacts through polarization, which shifts electrons and causes attraction through transfer of charge. It also interacts with induction, which can make a neutral object permanently charged. We saw that our predictions did not align with our results, since the amount of charge transferred and the positive strength of the acrylic rod directly affected what we observed.